Welcome everyone. Today I will solve some important problems of straight line and locus. So look, this is part, this is of part 4. Part 4. I have taken already 3 classes. This is for part 4. So problem number 1. Let L be a line joining origin and point of intersection of this. If L is perpendicular to this line, then find value of K. So directly the lines are not given. So pair of straight lines. It is given in terms of pair of straight line. So we have to find straight lines. So if we factorize 2x square minus 4xy plus xy minus 2y square plus 5 common 2x plus y. So this is 2x, so x minus 2y plus y common, x minus 2y, 5 into 2x plus y. Now 2x plus y and x minus 2y, 5 into 2x plus y equals to 0. So finally we are getting 2x plus y common, x minus 2y plus 5 equals to 0. So individual equations are, so 2x plus y equals to 0 and x minus 2y plus 5 equals to 0. Now we have to solve these two equation to find point of intersection. So this is 2x plus y. So what is y? Y equals to minus 2x. So x minus 2 into minus 2x. So this is 4x. Plus 5 equals to 0. So x equals to minus 1. X equals to minus 1. So what is y? Y equals to 2. So point of intersection. So this is our first phase. So point of intersection minus 1, 2. Minus 1, 2. Now L be the line joining origin and point of intersection of these two lines. So what is equation of L? L is a line joining 0, 0 and minus 1, 2. So y minus 2 equals to 2 minus 0, so minus 1. Into y minus 0, this is x minus 0. So this implies y plus 2x equals to 0. Y plus 2x. So let us verify again 0, 0 and minus 1, 2. So y minus 0, so 2 minus 0, minus 1 minus 0, x minus 0. So y plus 2x equals to 0. Now, if L is perpendicular to this, L is perpendicular to, so kx plus y plus 3 equals to 0. L is perpendicular to this line. So product of slope. So this is minus 2, slope of this, and this is minus k. This is minus k equals to minus 1. Equals to minus 1. Minus 2 and this is minus k. So k equals to minus half. So what is value of k? K equals to minus half. So this is simple problem. So you have to find, this is joint equation. So pair of straight line, you have to find separate equation of lines. Now number 3. This is also problem of Wbjee. 1 marks problem. So look, C is the reflection of A24 in x-axis. C is reflection of 24. C is reflection of A24. So this is A, so this is C. So this is 2 comma minus 4. B is reflection of C in y-axis. So reflection of C in y-axis. So this distance, this is B. So this both are negative. Coordinate of B, it is in third quadrant. So this distance is 2. So this is minus 2, this is minus 4. So this one is B. Then what is AB? What is AB? So AB equals to distance between these 2 points. So 2 plus 2 whole square. 4 plus 4. This is 4. So 2 plus 2 whole square. And this is 4 plus 4 whole square with square root. So 16 and this is 8, 64. So root over 80. So 4 root 5. 4 root 5. So mod AB is 4 root 5. So this is very simple problem of 1 marks. Now we consider problem number 7. So if orthocenter of the triangle formed by this and this is origin, then AB equals to. So is a rough sketch. So 2x plus 3y equals to 1. X plus 2y equals to 1. And this is ax plus by equals to 1. Orthocenter. So from vertex perpendicular from A, this one AD BE, this is orthocenter O 0 0. So perpendicular from vertex to opposite sides. So perpendicular from vertex to opposite sides. So they are called altitudes. So altitudes meet at a point. So the point of intersection is orthocenter. Now equation of line through intersection of 2x plus 3y equals to 1 and x plus 2y equals to 1. So you know 2x plus, so this is AD. 2x plus 3y minus 1. Lambda into x plus 2y minus 1 equals to 0. So this is equation. Now it represents AD if it passes through 0, 0. So since it passes through 0, 0, so minus 1 plus lambda into minus 1 equals to 0. So lambda equals to minus 1. So what is AO? AO or AD? So 2x plus 3y minus 1 minus x plus 2y minus 1 equals to 0. So this is x plus y equals to 0. So equation of AD we are getting. Now look, AD or AO, this is perpendicular to BC. So AD perpendicular to BC. So slope of AD is MAD into MBC equals to minus 1. So what is MAD? MAD is minus 1. And this is minus A by B equals to minus 1. So A equals to minus B. So A plus B equals to 0. So two unknown, A and B. So we are getting one equations. Now similarly, look, BE, equation of BE. So AX plus BY minus 1 lambda into 2x plus 3y minus 1 equals to 0. So point of intersection. Now it represents B if it passes through 0, 0. Since it passes through 0, 0, so minus 1 lambda into minus 1 equals to 0. So lambda equals to minus 1. Now what is B? Lambda is found. So ax plus by minus 1 plus minus 2x plus 3y minus 1 equals to 0. So a, x common, a minus 2, y common, b minus 3 equals to 0. So this is BE. Now second step. So BE perpendicular to AC. So MBE into MAC equals to minus 1. So what is MBE? So coefficient of x by coefficient of y, negative sign. Y equals to mx plus c. If we consider it right hand side, this. So what is MAC? MAC is minus half. Minus half equals to minus 1. So minus minus plus. So a minus 2 equals to 2 into minus 2 into b minus 3. So we are getting a plus 2b. A plus 2b. A plus 2b, this is 6. 2b, 2b, 2 into b minus 3. So 2b, so a plus 2b, this is plus 6. So this is 8. A plus 2b equals to 8. Now, solving these two equations, we get A and B. So A equals to minus B. a equals to minus b. So minus b plus 2b equals to 8. So b equals to a equals to minus b. A equals to minus b. So minus b plus 2b equals to 8. So b equals to 8. So if b equals to 8, so what is a? A is minus 8. So we have to find AB. So what is AB? AB equals to minus 8 comma plus 8. So this is most important problem for JEE Main. Orthocenter, three sides are given and orthocenter is origin. You have to find A and B. Now we consider problem number 8. Let A and B are two fixed points. The vertex C of the triangle ABC moves so that chord A plus chord B equals to constant. Then locus of the line C. Then locus of C is a line which is perpendicular parallel. So A and B, draw the figure. A and B are two fixed points. The vertex C of ABC moves such that chord A plus chord B equals to constant. So draw perpendicular. So this is CD. So what is chord A? Chord A equals to chord A. This is chord. So AD by CD. AD by CD. So what is chord B? So BD by CD. So from figure we are getting chord A and chord B. Now chord A plus chord B equals to constant equals to case A. So AD by CD plus BD by CD equals to K. This implies AD plus BD equals to K into CD. So this is AB equals to K into CD. So now AB is fixed. So AB is constant. So this is constant. So what is CD? AB by K equals to, again it is constant. So distance CD equals to constant. So look, from figure we are getting CD equals to K. So CD, AB is fixed, CD equals to K. Look, for all position, if it is C, so this is K, this is K. This one is also K. So what is locus of C? So look, this distance is same. So CD, this distance, this distance, this distance is same. So locus of C is a line parallel to AB. Obviously, locus of C is a line parallel to AB. This is a line parallel to AB. So this is also most important problem. Now we consider two more problems. So problem number 10 and 11. Look, problem number 11 first. An equilateral triangle has each side equal to A. Coordinate of vertices are this. Then what is value of the, this is determinant. Determinant whole square. So we need this idea. Area of triangle of vertices x1, y1, z1. So in terms of determinant, this is formula. Delta equals to this. So this is well-known result. So what we are getting, so x1, y1, 1, x2, y2, 1, x3, y3, 1 equals to 2 delta. So this is 2 delta. Now according to our problem, we have to calculate this. So this expression x1, y1, 1, x2, y2, 1, x3, y3, 1, total determinant whole square. So this is 2 delta. So 2 delta whole square, 4 into delta square. And we know area of equilateral triangle root 3 by 4 into a square. So whole square, 4 into delta square. This is formula of area of equilateral triangle. So this is 16. So root 3 by 4, a to the power 4. Root 3, this is root 3 whole square, this is 3. And 16 divided by 4, so 3 by 4, a to the power 4. So 1 marks problem of Wbjee. Very simple problem. So we need, this is in terms of coordinate, it is half of x1 into y2 minus y3, x2 into y3 minus y1, x3 into y1 minus y2. This is well-known result. And in terms of determinant, value will be this. Now problem number 10. So we have already solved a similar like problem in part 3. Now condition of concurrency of 3 lines. You know, since these and these lines are concurrent, so we use determinant. We can solve any 2 equation, find x and y, put this in third equation. So we get a relation. This is one process. But if we use determinant, so the 3 lines are concurrent. Therefore 1a, b 1b, c 1 equals to 0. This is condition of concurrency using determinant. Now it is a minus 1, b minus 1, c minus 1. So use c1 is replaced by c1 minus c2. c2 is replaced by c2 minus c3. Why? To get a minus 1, b minus 1 this type. So this implies 1 minus a. This is b minus 1. This is 0. This is 0. 1 minus b, c minus 1, ab 1 equals to 0. So we are using determinant. So if we expand 1 minus a multiplied by 1 minus b into c minus 1. Bracket close. 0 as it is, so plus a into, so this, so b minus 1 into c minus 1 and 0 into, so this is our result. So now 1 minus A into 1 minus B. B into 1 minus A, C minus 1, plus A into 1 minus B minus 1, C minus 1 equals to 0. Now look at the proof. So it is given in this form, A minus 1, B minus 1, C minus 1. So we multiply, take A minus common. This is A minus 1, B minus 1, minus minus plus. So this is plus B. This is A minus 1, C minus 1 unchanged. And it is given in according to proof form. So divide throughout by A minus 1 into B minus 1 into C minus 1. So what we are getting? 1 by C minus 1, B by B minus 1, A by A minus 1 equals to 0. Now these two terms are same. This is C by, but it is 1 by. So to get C by, so if we take 1 minus C minus 1 minus 1, suppose this one, so 1 minus C, 1 minus C plus 1. So 1 by C minus 1. This is 1 by C minus 1. 1 by C minus 1. And you have to write it in this form, C by this. So plus 1 if we add. So what we are getting? C minus 1 LCM. So 1 plus C minus 1. So 1 cancel. So we are getting C minus 1. So adding 1, this one unchanged, this one unchanged. So adding 1. So C minus 1 plus 1. So C by C minus 1. So after this step, look what we are getting. So C minus 1 plus 1. C by C minus 1. B by B minus 1 unchanged. C by C minus 1 equals to 1. Adding 1. So this is possible option. So lines are concurrent, determinant 0, and it is basically a problem of determinant. Now we consider two important problems. Problem number 16. So this is general problem. We have also solved similar like problem in part 3, but this is general one. The algebraic sum of perpendicular distances from ax1 y1, bx2 y2 and cx3 y3 to a variable line is 0. Then the line passes through orthocenter of the triangle, centroid of the triangle, circumcenter of the triangle. So variable line. So let variable line is ax plus by plus c equals to 0. A, B, C are variable. Then P1 equals to perpendicular distance from ax1 y1 to L equals to ax1 by1. So this. So P2 equals to from x2 y2 bx2 y2. So ax2 by2 plus c by a square plus b square. And P3 from Cx3y3. So ax3 by3 c by root over a square plus b square. So given P1 plus P2 plus P3 equals to 0. So this implies, so if we omit modular sign, so we get ax1 by1 plus c, ax2 by2 plus c, ax3 by3 plus c equals to 0, because same term at the denominator. Now a into x1 plus x2 plus x3 b into y1 plus y2 plus y3 plus 3c equals to 0. So a into x1, x2, x3 by 3 dividing by 3, y1, y2, y3 by 3 plus c equals to 0. Now look at this step. Our variable line is ax plus by plus c equals to 0. So here it is satisfied by x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. So the line passes through. The line L passes through, we can say passes through x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So that is, it is centroid of the triangle ABC. So you remember this result. If a variable line, if sum of perpendicular distance is 0, then the line passes through centroid. So if points are given, so no need of solving this. You find the coordinate of centroid. So the line passes through centroid of the triangle. Now consider problem number 14. So this is simple problem but lengthy. The midpoints of sides of a triangle are 5, 0, 5, 12 and 0, 12. The orthocenter of the triangle is 5, 0, 5, 12 and 0, 12. So midpoints are given. Here midpoints A, B, C. So 5, 0, D 5, 0. This is E 5, 12 and rough figure, this is F 0, 12. So this is x1, y1. So this is well-known problem of class 10, x3, y3. Midpoints are given, you have to find the vertices. So we are getting x1 plus x2 by 2 equals to 5. So this is 10. x2 plus x3 equals to, this is again 5. So this is 10. So x3 plus x1 equals to, x3 plus x1 equals to 0. And if we equate y coordinate, y1 plus y2 equals to 0. y2 plus y3 equals to 24. y1 plus y3 equals to again 24. So if we add this, so x1 plus x2 plus x3 equals to 2 into this equals to 20. So x1, x2, x3 equals to 10. So very simple. So what is x3? x3 equals to 0. So what is x1? x1 equals to 0. Now what is x2? x2 equals to 10. And this is y1, y2, y3 equals to 24. So y3 equals to 24 by 2. So this is 24. This is 24. So this is 48 by 2. So 24. So y3 equals to, what is y3? y3 equals to 24. y1 equals to 0. y2 equals to 0. So this is first part, problem of class 10. So what is A? A is x1, y1, x1, y1, 0, 0. And what is B? B is 10, y2 is 0. C is x3, y3, 0, 24. So look, you have to find orthocenter. So look at the points. So this is 0, 0. This is 10, 0. B. And A is 0, 0. And this is 24. 0, 24. So we are getting a right angle triangle. So no need of finding orthocenter by calculation. If it is right angle, then orthocenter is point of intersection of two perpendicular lines. So what is orthocenter? Orthocenter is O, 0, 0. Now if it is circumcenter, so midpoint of BC. So look, from middle points, coordinate of middle points, we are getting vertices. And we are getting a particular case, if it is a right angle triangle, then you know orthocenter is point of intersection of two right angles. So this is 0, 0. Now we consider one more problem, is last problem. O is origin and let A10, B01 be 2 points. If Pxy is a point such that xy greater than equals to 0 and x plus y less than 1, then you have to determine position of the point. So look, if we draw the figure, so this is A10, this is B01, O is origin, obviously O is origin. So we are getting a triangle AOB. It is given that xy greater than 0, xy greater than 0. So this means x greater than 0, y greater than 0. So Pxy in first quadrant is in first quadrant. And case 2, x less than 0, y less than 0. So Pxy is in third. So there are two possibilities, quadrant. So it is clear that P in first or third. Now one additional condition is given, x plus y less than 1. This is x plus y equals to 1. So less than 1 means this. So look, so Pxy. P cannot lie inside of AOB. So look, it lies in first or third, and this less than 1, that is towards the origin. So Pxy in first quadrant, this position is not possible. So 1, this is xy, inside of triangle is possible, or in third quadrant is possible. These are the two possibilities. Third quadrant, Pxy may lie in third quadrant. Look, left of this is in third quadrant. So Pxy in third quadrant, and if it is in first quadrant, then look, inside of triangle AOB. So look at the option. P lies either inside of the triangle AOB. It is possible. It is in first quadrant. And less than, so this is possible. Or in third quadrant. So this is possible option. B. P cannot lie inside AOB. So P cannot lie. So it may lie. So this is one possible case. It is not true that P always lies. This P may lie in this. So P cannot lie. So this is not possible. P lies inside AOB. Inside AOB. This is not possible. Inside AOB. Always possible is not. Because if xy greater than 0, so and Pxy here, then it is not inside. So A is possible option. Look it again. Xy greater than 0. So xy lies in first or third quadrant. So Pxy in third quadrant, and this line less than 1. So this type of figure is possible. So Pxy is in third quadrant. It is possible, or Pxy lies inside the triangle. So these two options, or Pxy lies in third quadrant, or Pxy inside. It is possible. P cannot lie inside AOB. So look, Pxy can lie inside. So this is not possible. P lies inside AOB. It is not always possible, because if Pxy lies in third quadrant, so this condition is not satisfied. So only A option is always correct. P lies either inside, look, this is or in third quadrant. So this is also a logical problem. So this is important problem also. So today we have solved some important problems of locus and straight line. So you solve the rest of the problem from description box. Thank you for today.